This is serious. This is a serious video. I've been joking for a while that these code review videos are getting a little bit dangerous, and I think we're finally there. A couple days ago, I put out this video where I reviewed a game engine written supposedly by an 11-year-old. And yeah, obviously sounds a little suspicious, but to me, with today's resources, still plausible. The email that was sent in certainly looked suspicious, you know, especially because of the mention anything you've tried, if applicable, placeholder. And like the use of language seems kind of advanced for an 11-year-old as well, but you know, like a parent could have helped out or some other older person. Also AI obviously could have played a part in it, so you know, not impossible. And the code, the actual code that was present itself also didn't seem too crazy to me. A lot of it could have just been from samples or documentation, you know, like this from the GLFW docs, for example. The code also could have been from videos, from like copying down code from video tutorials, as well as, of course, the answer to everything, AI. Could have been AI. Now, inside the submitted GitHub repository, there was also a precompiled binary, an exe file. There was also like this website where you could download pre-built binaries, and if you recall, I specifically said, want pre-built binaries, we're gonna leave that blue. You know, because for some reason people think I just recklessly open exe files that random people send me on the internet. Nah, sorry, I just don't trust you guys that much. But then, things got darker. The repository was wiped within a few hours of the video going live. People in the comments and on Discord started to speculate that perhaps something sinister was going on, that exe file was definitely malware. Now, obviously, since the repository got taken down, and I obviously cloned it before it got taken down, on my computer, I have the exe file. The exe file that I obviously definitely never ran. The exe file that you are all so suspicious about. So let's take a look at it. Something a lot safer and way more productive that you guys should take a look at is Brilliant.org, the sponsor of this video. For those of you who don't know, Brilliant.org is an amazing website filled with lots and lots of really high quality courses on various STEM topics. If you are just starting with programming, then I highly recommend you take a look at their computer science courses. They're just such a great introduction to beginners because they don't focus on a specific language, but they teach you how to think like a programmer. And the way that they teach is just so fun, engaging, and interactive. You'll actually have to like drag these things out to define the flow of the program. You won't just be sitting there consuming videos. Practice is the best way to learn. And then of course there's math. This fantastic way of teaching translates so beautifully to math, which I think really benefits from this kind of visual way of teaching. Playing with these widgets to see how the numbers actually affect the results is just so powerful, especially when you move on to more advanced topics such as linear algebra and calculus, which Brilliant teaches so well. And the best thing is you guys can take a look at all of their courses for free. They have a 30-day free trial that you can use to check out everything on their platform. Just go to brilliant.org/the Cherno, link will be in description below, or you can use the QR code on screen. And that link will also get you 20% off an annual premium subscription. Huge thank you as always to Brilliant.org for sponsoring this video. Okay, here it is guys, realengine.exe. This is it. So where do we even begin with this? Okay, actually before we begin, let me just mention that I am not a reverse engineer. I have had very, very little experience reverse engineering things. So if we end up finding nothing suspicious here, should you trust me? No, I wouldn't trust me. I'm still not gonna run this binary. Or maybe I should at the end of the video. That would be kind of cool, maybe. I'm more or less just gonna take a look at this for fun and just to see what I can find. If someone is watching who knows a lot more about this and, you know, may have noticed something suspicious that I missed, definitely leave it in the comment section below. But without further ado, let's begin. So the very first thing that I'm going to do is open up virustotal.com. This is just a website that, well, will analyze suspicious files like for us. So this is kind of like a no-brainer, just like a first step. Let's just give it to this website. And the result that we get over here is that 8 out of 63 security vendors flag this file as malicious. Now, I'm pretty sure last time I ran this, because I have actually done this before, like a couple hours before recording this video, I think it like said 75 security vendors or something, but it still came up with 8 being suspicious. And if we actually take a look at these 8 over here that have flagged it as malicious and a Trojan and all of that, we have some pretty decent ones here. We've got Microsoft, we've got Google. It just says detected for that. Microsoft says it's this. I actually don't know what that is. Malicious. This is apparently a Trojan. This is a Trojan.cryptic, which if, by the way, you Google these things, then you can see that like this is a malicious program designed to electronically spy on the user's activities. Now, the thing is that virus detectors, virus scanners, they very often have false positives. I'm absolutely not saying that this exe is safe. I'm just saying that like, I don't know how much I can trust this. Now, again, Microsoft saying that it's bad and Google saying that it's bad leads me to believe that it's probably bad. But the thing is, I would like to know why it's bad. I want to go way deeper than this. If we have a look at some other EXCs that have been submitted to me, so this is like from the Cute Farm code review I did a while ago. I'll have it linked up there. I think we may have tried to run this. In fact, I'll just run it now. And we couldn't run it because these like DLLs were missing. But if we go over here and we upload this, so it's going to do some static and dynamic analysis on it. I think this website also actually tries to run it in like certain sandboxes. And in there, like it looks like it had 0 detections, no network comms. I don't really know how to read this. I'm literally reading this for the first time. MITRE tactics. I don't know what that means. Parse, PE, portable executable. I'm guessing header, link many functions at runtime, link function at runtime on Windows. Yes, that's how programs work. Hijack execution flow. Anyway, back to the Cute Farm exe. Yeah, I mean, this says 0. Right? So what does that mean? That means that maybe because they're using similar libraries, like they're using GLFW, they're using, I don't know if this was using IMGUI as well. I was just trying to make sure that this wasn't a scenario in which it was marked as malicious by like, it was marking like everything as malicious. But anyway, yeah, concerning that it's, you know, marked as malicious, but you can see that also the rate of it being marked as malicious is tiny, right? So again, you know, that why are these not detecting this? Okay, so AVG had a timeout. Can I reanalyze this? Let's see if maybe we can get it some more to analyze it. Okay, so we got a new one here. Sky High behaves like Win64 coin miner. And now we've actually got 11 out of 73 marking it as malicious. The reason why I say this is interesting is because if we actually go to, from the original email, if we go to the website and we have a look at GitHub, notice how this is still blue, obviously. So this is the repository. You can see that it's been changed, and 2 days ago doesn't make sense because actually, hang on a minute, maybe this changed before I uploaded the video. Because if this is in fact 2 days ago, like dates can be spoofed, obviously. So it's like, it's really hard to actually trust this. But obviously, like I recorded the code review like last week or something, and the video was just published like, I don't know, 12 hours ago or something, 18 hours ago actually. So it's weird that everything seemingly has been stripped. But if we go to this 1234.5 Anthon account, right, then you can see that we got some like Dogecoin going on. Right, now these are some really weird repositories. This whole thing is definitely weird, but all I'm saying is that seeing that it's a coin miner, there's some relation here obviously between Dogecoin, which is a cryptocurrency, and something that mines coins. But anyway, my suspicions are pretty high at the moment that this is in fact a Trojan. But what is the Trojan doing? Or to put it another way, curiosity killed the cat. We're gonna have to investigate further. We're gonna have to potentially go down with the cat, but it's gonna be worth it perhaps for content. So the next step here for me is gonna be to use something like Ghidra, which is this reverse engineering framework developed by the NSA. It's basically gonna let us decompile the code and obviously help us a lot with that. But yeah, it's like an entire reverse engineering framework. It's completely open source, it's free. The only downside is it's written in Java and requires a JDK, but we can forgive that. We can move past that perhaps. I'm joking, by the way. So let's take a look at this exe file inside Ghidra. Here we go, realengine.exe. So I'm just gonna click on this dragon and we're gonna watch the cool animation actually that plays when we click on that dragon. Oh, look at that. And then what we see here is a program that I have very little experience with. Now I have used other kind of reverse engineering decompilers in the past, mainly IDA. In fact, I'm pretty sure only IDA, and that was like 10 years ago. So anyway, if I go file open, I can pick my real engine exe. Let's analyze it. And we'll go through and everything's basically checked here except for the prototype things. Let's just click analyze. So while it's analyzing, hopefully like my plan here is just to see what this is actually doing, right? Like what functions is it running? What is this potentially malicious code trying to do on my computer? And in fact, can we actually even find anything malicious within this? This is going to be interesting. Okay, auto analysis summary. This is mostly just stuff that I guess it couldn't decompile or it couldn't find. Illegal argument for source map info. I don't really know what any of this means. Whatever, we'll just click OK. So it looks like it's automatically parked us over here at the main function. And you can see here that basically what we're looking at here is just the disassembly. So it's kind of decompiled the machine code, which looks like this, back into actual assembly instructions. And then it's done its best to actually try and find symbols for it. Now, this is almost definitely a debug build is what I was going to say. It's marked as a release, but by debug build, I just mean the fact that there's a PDB here just means that debugging information is in fact included, and we can actually see, you know, things like application.cpp line 32, which clearly wouldn't exist if this was like a binary where all symbols were stripped. So this is actually really advantageous to us. Otherwise, we'd be much harder to actually make sense of what's going on. Over here on the right, we have like this decompile main section, and you can see what it's done is it's tried its best to actually reassemble all of these actual assembly instructions back into C++ code. Now, obviously, it's going to look very different from the original code because that code goes through pretty intense transformation, especially if this is in fact a release build, meaning that it's got some optimization applied to it, things like functions being inlined. That stuff is definitely going to make the code a lot harder to follow and relate to the original code, but you know, in the grand scheme of things, not that hard compared to if it was just assembly. I want to quickly point out another tool that I love using called HXD. This just lets you, it's basically like a hex browser, I guess. It just lets you put in any binary file and it will show you the hexadecimal representation of the binary, as well as trying to decode every single number here into ASCII characters, which is what we see here in the decoded text. The reason why is because this just lets us instantly see what strings are actually contained within this. We could expand this a little bit just to focus on this section. Now, this is pretty annoying still to look at, but if we scroll down far enough, you can see we run into a whole bunch of text. So these are all like OpenGL functions that are probably being loaded by their actual name. And then there's like so many other strings. Honestly, the best way to probably look at strings is this command called strings, which you'll have to download from sys internals. I don't know why I'm writing it. Microsoft have like a strings release for Windows because traditionally it's like a Linux command. I'll have this linked in the description below. But basically the idea is I can just type in strings and then realengine.exe. I'm going to output it to a file just to make this more manageable. And if we have a look at this strings file that is generated here for us, then this is what it looks like, right? So every string from that binary, a lot of them are just not really strings, but you can see it's put every string into its own line. Now, what is this good for? Well, strings inside your binary, in a way, can't really be avoided, meaning that like, unless you literally encode every single string literal that is ever used, which especially if you're using like third-party libraries would be like a lot of work, then anything in the code that appears as a string literal. So this is the actual C++ code that was in that repository. This string literal, because it's just defined like this in quotes, like literally will be within the binary. So I can search for it and here it is, starting real engine, right? So the reason why I showed you all of this is because at the very least, this shows us that these are related programs, right? Like a lot of what's going on here, such as this shader that is going to try and load, fail to create GLFW window, all of these actually are going to appear, you know, somewhere inside the code base. So this just very quickly shows me that this exe is at the very least related to the actual source code that has been submitted. Now, does this mean it's safe? Well, of course not. There could be something within this code that is in fact malicious. Now, there probably won't be within the code I've looked at because I did actually look at it first, you know, before compiling and running it, because I don't tend to just blindly compile and run code that was submitted to me. However, the included binary may in fact contain additional C++ code that was stripped from the actual source code release. Going back to Ghidra over here, if we have a look at this main function, which you can also find over here under functions and then M, and then we have main, right? So this main function over here is the entry point of our program. You can actually see over here, if you go to main CRT startup, which is like the function that actually calls main, here's the main CRT startup function, it will call this common main SEH function. I don't even know what that stands for. And then that function will call our main function. So it's a very standard C/C++ program at this point. And then what do we do here? Well, you can either try and read this, or you can just look at this decompiled code over here, pointer/primitive types or whatever. They don't really matter because they're not assigned to until later. So you can see the first real thing that happens is this log gets created. And if we have a look at the actual C++ code that we have here inside the project, we can see we have int main, which creates this like real class instance, which is up here. And then this class has a constructor, which will in fact call the log constructor. And that's what we're seeing over here. Then you can see it's doing some operator like left shift or whatever with basic ostream. And then it's passing in this string over here, which is info. So you can tell that log.info is being called, and then what does log info do? Well, it has this info text along with the message being log constructed, being printed. So what I'm seeing here is that this compiled exe file seems to obviously follow what is actually going on inside the source code that was provided. Now, obviously at this point, you're not gonna just go through like all of this code and actually try and like see if it's doing anything malicious. So another thing we can do to quickly see if it's calling any suspicious functions is actually having a look at this symbol tree over here. And then we have imports, exports, and functions. These three are probably like the most important ones to look at. So functions are all of the functions that are actually inside this compiled binary, so inside the exe file. Now, obviously, since this exe file uses other third-party dependencies such as glfw and it links them statically, that means that all the glfw functions are actually going to be within here as well. And if we expand GL, then you can see we're going to see those glfw functions, right? So that's not going to be an import because it's not importing it from a different module. It's actually in this current module. Exports are what it would export, which it's not really like a DLL. So we just see like the main CRT startup function. And then imports is interesting because that's all the DLLs that it actually imports, that it actually opens up and runs functions from. So this can be telling, I guess, when it comes to like, is this doing anything destructive? Because this API is really what lets us do destructive things, right? Like, for example, I don't know, deleting files or sending data over the network or keylogging or running other processes. Like, that's what we would see being used from like the API that we have on our operating system. So let's just have a look at this. So we have like convert, which obviously are just utility functions. We have file system doing lock file and unlock file. We can click on these to see where they're called. CRT heap is just like memory allocation. CRT locale is just, I don't know, config thread locale, which doesn't really matter. Math, we've got some math functions, runtime. Anyway, we could go through like literally all of these and just see like what they're doing. Like we have some file operations going on over here as well inside standard IO. But what you can also do is just use this filter search over here to actually search for things that you might consider suspicious. So process execution. If we just search for process, you can see that we've got some function calls to get current process. And if we have a look at where that's actually happening, so this is the actual function, but this is the reference to it. So that's where it's getting called from. So you can see that get current process is just coming from raise security failure, which is just like an assertion slash like debugging, I guess. Get current process ID, same situation. These are all like built-in functions. If we expand this a little bit, we've got set process DPI aware. None of this stuff really does anything malicious. There's no like create process or anything that would be potentially bad. If I have a look at like, because there's like shell execute. So let's have a look at like execute or something. Okay, so shell execute A is in fact being used. Let's see where. Okay, so it's happening inside platform open in shell, which I think, okay, you can see over here that it's doing platform open in shell default implementation IAM-GUI context. So yes, this is an IAM-GUI function. And if we have a look at where that's actually being used, I don't know if there's an easier way to do this, but if we just open up this function, we can see where it's being called from. It's being called from initialize. If we have a look at initialize, you can clearly see that this is an IAM-GUI function that's initializing stuff. If we actually wanted to see this as well, I'm sure we could probably search for it. And here you go. Here it is over here within the IAM-GUI code. So this function exists within IAM-GUI, probably like to open a web browser, to open like a URL, for example. I don't think there's anything malicious really going on here. And you can see, by the way, that because we have that debugging information, it literally tells us where. IAM-GUI.cpp line 15,028. So if we go to line 15,028, you can see there's that platform open in shell default implementation function. So yeah, whilst that could be used maliciously, it's probably not. We do have another reference to this function that doesn't have a name, which might seem a little bit suspicious. I'm not even sure what this is. This is probably like some kind of function table or something. Okay, what about files? Let's have a look at what files we could be opening here. So IAM file open is an example of this, probably to like load fonts and stuff. Honestly, it's not even used that much. You can see that fclose is used by a whole bunch of different things. Again, like update settings, log finish, shutdown, IAM file load to memory, all completely not suspicious. IAM-GUI uses IAM file open, and that uses WF open over here, which is the reference we're seeing. Okay, so what else is there? Like key logging stuff. Like I think there's a function called set windows hook or something. Doesn't look like anything bad here. What about like get async key state and key related things? So get key state is, you'd expect that to be used because obviously there are functions like glfw get key. So we clearly need to get information about it. These are just a bunch of constants like strings that are set to certain literals here, because you can see that that's inside like the labels section over here. But then yeah, get key state. So, well, I mean, let's have a look at what this is. So you can see that there's a whole bunch of stuff here that are specifically from glfw. So glfw poll events will actually get the key state, obviously, of the keys on your keyboard. But then there's all these functions, and these do seem like a little bit suspicious because they don't have names. But if we click on one of them and have a look at this, these are probably also going to be like glfw functions, to be completely honest. Let's see if I can find this, for example, inside the actual source code. So get key state. So let's see if glfw would be using that. Now, GLFW here is obviously provided as an already compiled binary, which does complicate things. It could mean that certain things are malicious within that binary. It could be like a fake GLFW3 binary. Now, it is statically linked, which means that we would be seeing all of its code, like potentially this here. However, what I have over here is Hazel. I've just opened up the Hazel solution, which has GLFW source code in it. It's probably just the fastest way to open GLFW for me. You can see there's a whole bunch of Win32 things. So what I'm gonna do is, where would this be? Like, let's have a look, maybe in window. So get key state. Okay, so we have a whole bunch of get key states, and you can see that a lot of them actually have like all these if statements, and they call the function multiple times. So to be honest, this is already beginning to seem like it might be this, because you can see here are some if statements as well. How do we know? Well, this is get key state 90, that's 14. So if we have a look at this, you can see that numlock is in fact 90, and VK capital is in fact 14. So this is probably what's going on here. I don't know why I couldn't get that function name, and all of the other symbol names possibly weren't included with GLFW because, again, we didn't compile it from the source code, but that obviously looks pretty safe to me. Threading situations, because I'm guessing that if it was some kind of crypto mining thing, it'd probably have to spin up a thread. Let's see if we create any threads. Again, I would expect some of this stuff going on potentially within GLFW. It doesn't look like we're really starting any threads. So we've got set thread execution state. I wonder if that is malicious. So we've got two functions that is being called from. One of them is clearly a GLFW function. So we've got this function with no name here that's calling set video mode and set input monitor window. So again, if I grab that, I'll just grab this function, and then inside Hazel, maybe in thread. Okay, let me just search for that whole thing. Okay, it's in Win32 window and monitor. So if we have a look over here, wire monitor, release monitor, you can see that it's setting the thread execution state. And if we just kind of compare these here, so we got set thread execution state system parameters twice. You can see we got set thread execution state system parameters twice here, and then set video mode and input monitor window, which is what's happening over here. Okay, so what is this program doing? I don't really know, to be honest. Could it be loading other libraries like dynamically and stuff? I mean, load library A is being called from OpenGL3. So you can see over here that it's loading OpenGL32.dll, which is pretty standard. And then GLFW platform load module. That's loading all of the necessary things I'm expecting. But again, if you have a look over here, you can see what it's actually loading. So these are all specific functions that it's loading from like user32.dll. It's doing so dynamically, meaning rather than being like a fixed requirement within the binary, so it's like kind of half statically linked, but it loads a function dynamically automatically. It's the actual C++ code of the program that's triggering the load whenever it wants. Okay, well, anyway, I could probably sit here all day and look at this, but the main thing is that I'm not really seeing anything malicious at all. We can also, by the way, go to window and define strings, because I talked about strings. Whoa, with that animation. That's pretty cool. And you can see that like here are all of the strings in the program. So if it was running like, I don't know, cmd.exe, or like if it just had anything like mine, I don't know, like would it really say stuff like that though? Probably not. Trojan. You know, you can browse the strings here. We already basically did that by dumping them to a file, but you can also do it within Ghidra. Look at me, I'm an expert in this program now. It's even got like hello world in here. Like, why does it have hello world? So hello world is inside like the I'm GUI. Okay, well, these are comments. Okay, here we go. I'm GUI log text hello world. Right, I'm GUI demo.cpp has like this demo window that has a bunch of functions demonstrating what you can do with I'm GUI, and that would be what's calling that. Anyway, I think it's fine. What should I do next? Because the fact that why does this think, what is it doing that makes it think that it's a Trojan? What could it possibly be doing? Registry keys open. Okay, so we didn't actually have a look at that. Reg. Again, not really seeing any of that. As far as I can tell, with my like 60 minutes of decompiling reverse engineering experience, pretty much most of which you've witnessed in this video, I can't see anything malicious at all inside this code. It seems to me to just be the compiled version of all of this stuff. Like it literally all seems to be there. So am I gonna declare this file as safe? No, of course not. Why? Who do you think I am? However, However, did you see something suspicious in this video? Did I miss something? Should I try something else? If you have more experience than me in this, please send me a message on Discord or something. Let's talk about it. Show me some stuff. I'd love to make another follow-up video being like, yes, it was in fact a Trojan. Here is why. But as of the time that I've spent on this so far, I can't find anything malicious in this exe file. Thank you for watching. Till we meet again.